Hey everybody, welcome back. We are looking at our normal distribution curves again. And we just had a long winter break here, which will make using this video interesting for future years. But so long winter break, I'm going to do a little bit of a review for us. And I'll go back to the start of this chapter. And this chapter was on normal distributions. So here is our bell-shaped curve, a normal distribution. And our previous chapter was uniform distributions, those rectangular shapes. And inside of this, we talked about how we write this with an N, capital N for normal, and mean and standard deviation. And then we're going to go ahead and use that information to find probabilities. And here we had the IQ scores with percentages. We had the percentages within one standard deviation of the mean. We calculated those z-scores. And we learned these. We don't really need the z-scores or the empirical rules too much anymore because we have these online calculators for us. So for these calculators, we typed in the mean, the standard deviation, and we searched above 65, and it told us it was about 34% above that. Here we're going to be learning how to use a new calculator called the inverse normal distribution calculator. It's going to be useful when they give us a probability, and then we have to work backwards. So let's do an example. So farmer grows oranges with a mean diameter of 5.85 centimeters and a standard deviation of 0.24. And find the probability that a randomly selected orange from this farm has a diameter larger than 6. So to do this, if they give us the mean, the standard deviation, and they should also tell us that this is grows oranges that are normally distributed. There we go. So now we know that it's a normal distribution. So to find oranges that are the probability that oranges are bigger than 6, what we're going to do is go to our normal distribution calculator. And then we use our information here. So this had an average of 5.85, standard deviation of 0.24. We were looking for above 6. There it gives us our labels. So to go above 6, we get 0.266. So about 26.6%. And there's our first one. All right, and that's what we worked on. The previous work was finding those probabilities. So we could say 0.266 or 26.6% chance to be larger than 6 centimeters. The next part is asking us if they give us this information. So the middle 20% of oranges on this farm have diameters between blank and blank. So to do that, if they give us a probability first or a percentile, that's where we need to work backwards. And we go to the inverse normal distribution. Go and type in inverse normal distribution calculator. And here we type in the same information, our average, our standard deviation, and we are looking for the middle 20%. So the probability is 20%, so that would be 0.20. And we're looking down here, they give us some options. Above, below, they show you there, between, or outside. And we are wanting to know the between. And there it tells us between 5.789 and 5.911. Between those values, 20% of our oranges lie. It's pretty slick. Oranges in the top, in the 90th percentile, the top 10% have a diameter equal to or larger than blank. All right. So this one we're looking for the 90th percentile. here we can see below, that would be 90% are below. Above, that would be 90% are above that score, but we're looking for the below, right? Because we're looking for the high number. So 6.158, that's the high number, where 10% of the oranges are above it, 90% are below. We could also change this. We could do 0.1. If we did above, there we go, 6.158. We see the same number there. Okay. And there we go. The middle 40% of the oranges. That one, we just go back. 0.4. And this one is between. So there we get our numbers for the middle 40%. Find the 16th percentile and interpret it in a complete sentence. So the 16th percentile, that tells us that we need to find the number that 16% are below that. So we type in 0.16. We look for below because 0.16, 16% will be below it. So 5.611. So an orange at 5.611 centimeter diameter has 84% larger than it and 16% less than it. The interquartile range of the oranges. Hint, remember the interquartile range is the difference between the 75th and the 25th percentiles. So we need to find the 75th and the 25th percentiles. So the 25 percentiles, 5.688. And 75th percentile is 6.012. So we would take the difference between those numbers. We just subtract them. All right. So that's an inverse normal distribution. I think I'll just stop there because I like those examples. And yeah, let me know if you have questions.